right, this quick video is to just help you understand a piecewise function for your homework tonight. So f of x is a piecewise function. And I know when you first look at this, it can be really confusing to look at if you've not seen this before. But let's start with the right side of it. You could think of this part of what we're looking at. So we see f of x, we see the function -2 to the power of x. And in fact, right now, I'm going to go ahead and put parentheses around this so we don't make a mistake, because that's really the order of operations tells us to do exponents before multiplication. So that negative is on the outside. But I understand this is confusing. But where these are separated by a comma, where the function is separated by this inequality, we could almost break this up into, I can almost put a line here and think of this almost as a set of instructions. And it's telling us that when we're evaluating this function for a value in this domain over here, that we are going to use either this function, or this function, but we are not going to use all three. So let's just take a look at the top part. When f of x is equal to -1 times 2 to the power of x, that's going to happen when x is less than -4. So on this just numbered line, I'm going to think of this like my x-axis over here. If I go to -4, because x cannot equal -4, I'm going to put an open circle at -4, and just like I'm shading this inequality, I'm going to shade over here to the left and say, all right, x could be anything not -4, but it could be -4.00001 and anything less than that, you know. All right, so in the second function, so f of x equals, this is like saying -1 times the absolute value of x. So f of x will be equal to this function when x is greater than or equal to -4, but less than or equal to 0. So now, since x can equal -4, I'm going to put a closed dot on the -4. X can equal 0, a closed dot, and then I'm going to shade what's in between. And this isn't something you have to do every problem. I just want to make sure we kind of walk away with understanding piecewise functions. All right, lastly, for the third function, f of x equals 4 minus x squared when x is greater than 0. So I'm going to come over here and say, all right, when x is greater than 0, not equal to, I'm going to do an open circle and shade everything greater. All right, and these are just all my x-axes. All right, so now if I look over here for this particular piecewise function, and this is not always the case, but for this one, it's defined from -infinity to +infinity. So the domain of this function, I'm going to write it in interval notation, is negative to +infinity. So when I look at that, this domain is broken up. When it's anything less than -4, I use this function. When it's anything between -4 and 0, including -4 and 0, those sort of endpoints, we could think of them as, or almost like boundaries, I'm going to use this middle function. And then lastly, when it's when our x value is anything greater than 0, I'm going to use this third function. All right, so now we can pretty quickly evaluate f of x at these 4 values of x. All right, so for the first one, f of -5, I'm just going to think about that. Where's -5 on my number line? It's going to be less than -4, so I use this top function. So when I do this, now I'm using essentially f of x equals -1 times 2 to the power of x. That's how I like to think of that. We really need those parentheses there. All right, so I'm going to substitute a 5 in, or -5 rather. So -1 times 2 to the -5 power of -5. All right, from here, this is just some algebra. So I know when I have my negative exponent that I can really say that this is going to be 1 over 2 to the +5, and then multiply this by -1. And 2 to the 5th power is 32. So this is -1 32nd, if you will. All right, and that's what we get when we evaluate this at f to the negative 5. Excuse me, f of negative 5. All right. Let's see. When I look at the next one, negative 4, we want to be really careful here because we see negative 4 in both of these inequalities, but we ask ourselves, where does x equal negative 4? So I know x is greater than or equal to negative 4. I'm going to use the second and less than or equal to 0. I'm going to use the second function. And if you're visual like I am, I like to look at the number lines. All right, we're looking at this. So I'm going to use f of x equals, I'm going to think of this as negative 1 times the absolute value of x. So I'm going to substitute a negative 4 for x. So f of negative 4 equals, bless you, that's my office mate, equals negative 1 times negative 4, the absolute value of negative 4, excuse me. So the absolute value of negative 4, remember that's just a number's distance from 0 on the number line. So since I'm 4 units from 0, the absolute value of negative 4 is just 4, but I still have that negative outside of the absolute value expression. So that becomes negative 4. All right. Then we're asked to evaluate this function when x is 0. So again, I have to think, I'm not going to use all 3 of these functions. I'm going to use the piece, that's why it's called piecewise, the piece of the function that corresponds to the interval where x is equal to 0. So this one ends up being our middle function again, because x is 0, or I can see x is less than or equal to 0 here. So I'm going to say, all right, f of 0 equals negative 1 times the absolute value of 0. The absolute value of 0 is 0, and negative 1 times 0 is 0. So that one's easy. And then for the very last one, if we evaluate f of 1, I'm going to use the third function because 1's greater than 0. So on my number line, 1 is greater than 0. I'll use this. So I'm going to use f of x equals 4 minus x squared. And then I'm going to substitute that in. F of 1 is 4 minus 1 squared. We know 1 squared is 1. 4 minus 1 is 3. So f of 1 equals 3. All right, I hope that helps you at least understand the basics of a piecewise function.